if velocity and acceleration are in same direction. Speed will increase. Do you remember what is speed? Or you don't?
Yes.
What is speed?
Magnitude of velocity.
So, what is speed is the magnitude of velocity. So, we are saying that if v vector and a vector are in same direction, then the speed will increase. Okay. Number 5, opposite of this, if v vector and a vector are in opposite direction, then speed will decrease. Then speed will decrease. Okay. This type of motion where speed decreases is called retarded motion. Retard means to slow down. Object will slow down. In retarded motion, the object will slow down. Right? The speed will decrease. Example of retarded motion is when you're going on a vehicle and brakes are applied. What will happen when brakes are applied? Speed will decrease. Any kind of situation where speed decreases, that is called retarded motion. Right? There are so many examples that you can think of this way. If you are running, you slow down, that is retarded motion. Did you get that? Yes or no? Do you have to remember what is the meaning of retarded motion? Right? When the object's speed decreases, that's called retarded motion. Now, why is it like this? Let's try to understand both of these ends. Suppose some object is moving, let's say, towards the right side. Okay, some object is moving towards the right side. Do you remember object always moves in direction of velocity? Yes or no?
Yes.
Right? That was one of the sentences. So when I say that there is some object is moving towards the right side, what that really means is that its velocity is positive. Take it this way. What it means is the velocity is positive. Now if velocity is positive, right? Suppose it is plus 20 meter per second. That means 20 meter per second towards the right side. And let's say acceleration is minus 5 meter per second square. Unit of acceleration is meter per second square. Correct or not? Now you see the simple meaning of velocity is that in 1 second how much is the displacement? I repeat. This you probably know, I'm just saying it so that it clicks in your mind. I'm saying that simple meaning of velocity is as follows, that in 1 second, per second, how much is the displacement? That is 20 meters. So in 1 second it is going to move 20 meters. That is what velocity means in a very simple manner. Just like that, what does acceleration mean? If you want to understand what is meaning of acceleration, you can think of this unit like this. It will give you a better understanding. What this is saying is that velocity will change by 5 meter per second per second. I repeat what I have said. Suppose someone says acceleration is minus 5 meter per second square. What that really means is this, that the velocity will change by 5 meter per second in 1 second. So, because this is negative, suppose this is at t equal to 0. And if the same acceleration continues, then after 1 second, the velocity will become 15 meter per second. Did you understand?
Yes.
Yes, no?
Yes.
Why 15? Like I said, in 1 second, the velocity will change by how much? Minus 5. Is that okay? So, from 20, it will become 15. After 1 more second, the velocity will become plus 10 meter per second. Did you understand? That is this value of acceleration. What it is telling you is that every second the velocity will change by 5 meter per second, and minus means it will go towards negative. Do you remember one sentence? Change in velocity. I think the first one in this list. Change in velocity is always in direction of acceleration. So here the acceleration is negative. So gradually the velocity is changing towards the negative side. So from plus 20, 15, 10, there is a negative bulge, right? Yes or no? I hope you are seeing that.
Yes.
So that is what happens, right? So at t equal to 3 seconds, then it would become plus 5. So read this thing. If velocity and acceleration are in opposite direction, velocity is in which direction?
Plus.
Positive, right? Acceleration,
Left side.
okay or not okay?
Yes.
Sure.
Yes.
Okay, so they are in opposite direction. Correct or not? That means there is retardation or retarded motion, and that means the speed will be decreasing. Is the speed decreasing? Let's check. First it would be 20, then it will become 15, then it will become 10, then it will become 5. Yes or no?
Yes.
The speed is decreasing. Did you get that?
Yes.
Right? This is exactly what happens when you apply brakes to a vehicle. Suppose the scooter is moving at 20 meters per second and you apply brakes. So acceleration will be in opposite direction. So gradually the speed will decrease and it will come to stop. Did you get that? Okay. So like for example at t equal to 4 seconds, velocity will become 0. It will stop. But yeah, then if acceleration continues further, then the velocity will become minus 5. Is that clear or not?
Yes.
Now object will start moving in which direction? Left side, negative side. If velocity is negative, it means object is now moving towards the left side. Is that okay? How high? Is it possible? Yes. Did you see that? First pen goes up, and as it goes up, I'm sure if you have played with ball, you have realized that if you try to toss it up or throw it high up, it will not go faster. Then gradually as it goes up, it just seems to flow down. Have you noted that?
Yes.
Or a shuttlecock when you play badminton. Then also you might have noted that when you hit it, it zips. But then gradually as it goes up, it will slow down. Yes or no?
Yes.
Right? So at that time there is retardation. And then at one point velocity will become 0. After that what will happen? Yes, the velocity will be now in opposite direction. If upward was positive, then downward would be negative. So acceleration will bring it back. So velocity will now turn negative and then it will come back. Did you get that? Okay. So sentence number 5 here.
Yes.
Sentence number 4 is exact opposite of that. Suppose instead of minus 5, this was plus 5. Now velocity is in which direction?
Positive.
Acceleration positive. After 1 second, instead of 15, it would now become 25. Speed is increasing. After one more second, it will become 30. Is that okay or not okay? So like that, the speed will keep on increasing. So that's sentence number 4. When velocity and acceleration are in same direction, the speed of object increases. And when velocity and acceleration are in opposite direction, the speed of object will decrease. Clear?
Yes.
This type of motion, right, where the object speed is decreasing, that's called retarded motion. Yes, Neil? Neil, you have to say a little bit louder. Okay, sit down. The truth is that nobody will write acceleration in this way, but when you write like this, it becomes easy to see what is going on. So what this is telling you is that first of all, do you realize that acceleration is something that is related to how quickly velocity is changing, right? How quickly. So acceleration being suppose plus 5 meter per second per second. What does it mean? It means that in 1 second, the velocity will change by this. Did you understand? In 1 second, velocity will change by this 5 meter per second. Got it? So if it was 20 meter per second, then it will change by 5, means plus 5. That is, it will become 20 like that in 1 second. Did you get that? Sure? Clear? So that is why I have written it as 5 meters per second in 1 second or per 1 second. Think about it. Let's say, okay, let's consider it. Have you ever downloaded files from the internet? I'm sure you would have. Okay, apps or files or anything. Then, let's say you want to download a slightly larger app, probably 200 MB. Then you would have noted that sometimes at start, the download speed is not that high. right? Maybe 100 kbps, 150 kbps. Then after some time, what will happen is that the downward speed will increase. So acceleration is exactly that. It tells you how quickly the speed is, actually not speed, but velocity. How quickly the velocity is changing. If velocity is increasing, acceleration will be positive. But if velocity is decreasing, then acceleration will be negative. See, I am not saying speed, I am saying velocity. So from 20, if acceleration is positive, that is plus, then it will become 25. Then 30 and so on. So again, acceleration tells you in 1 second what happens to velocity. And velocity tells you in 1 second what happens to position. Think about that. If someone says velocity is 20 meters per second, what that means is if it was here, then after 1 second it would be here. Did you understand? Yes. Velocity tells you what happens to position in 1 second. 20 meter in 1 second or per second. Clear change of 20 meter in 1 second, that is velocity. So position will change from 0 to 20 in 1 second. Similarly, what does acceleration tell you? How much does velocity change in 1 second? Is that okay?
Yes.
Right? So if velocity is not changing at all, then we can say that acceleration is 0. Yes or no?
Yes. Yes.
Because acceleration indicates the change of velocity. How quickly velocity is changing. If we say 0, it means it's not changing. Velocity is constant. In fact, that's what we have written on velocity. Yes or no?
Yes.
Right? In uniform motion. Check that. Check it. What have we done by using some maths is that if acceleration is 0, that is only possible if velocity remains constant. So after 1 second also it will be 20, after 2 seconds also it will be 20 if this is 0. Alright, everyone got these sentences?
Yes.
Anything else comes to your mind? If yes, please ask. Alright. Next. In case of retarded motion, actually I just want you to add one word, hopefully you have space. Add a word here also. Retarded motion or retardation. Okay. And word, then we'll go to this. In case of retarded motion, magnitude of acceleration is called retardation. So here this word retardation has two meanings. So you have to be a little bit careful with it. Retardation means the phenomena or process. You understand what is the meaning of process?
Yes. Yes, sir.
Yes or no?
Yes.
Fan spins, that's a process. But you find fan speed, that's not a process, that is a quantity. Is that okay?
Yes.
Sure?
Yes.
A person runs, that's a process. But how much the person runs, that's a quantity. Maybe displacement or distance. Did you get that?
Yes.
So just like that, when some object speed is decreasing, we call that kind of motion either retarded motion or we also call it retardation. Okay.
Yeah.
But another meaning of the same English word is this, that if there is retarded motion, then the magnitude of acceleration is also called retardation. Okay, the magnitude of acceleration is also called retardation. Let's just take an example. Suppose it was like this. Okay, and if I ask you in this case, is it retarded motion or not retarded motion? Plus 20, minus 5, retarded motion or not retarded motion?
Retarded motion.
Obviously, this condition is true. Yes or no?
Yes, sir.
Okay, now in this case, if someone would ask you, what is the value of retardation? What is the value of retardation? Then it will be 5 meters per second. Did you understand why not minus?
Yes, sir.
The modulus over acceleration. The magnitude of acceleration, magnitude means you have to take a modulus. Magnitude of acceleration is called retardation in that case. Not always. Huh? If it's like this, If it's like this and someone asks you what's retardation? No, wrong question. There is no retardation. Is this retarded motion?
No.
So પછી retardation શું? Did you understand?
Yes.
This is not retarded motion, so that's why there is no scope of retardation. It's like asking, what is the color of elephant's egg? Bolo, answer apo. What is the color of elephant's egg? No color?
No.
Or there is no egg?
No egg.
Oh, no egg. Okay. So that's the thing. If it is retarded motion, only then you can define this. Otherwise, there's no need. Okay, the question itself is wrong. Be careful about it. Alright, so that's about retardation. Yeah, and a big warning that I want to present to everyone, because some books sometimes, I don't know where you might read it by mistake. Big warning here. Okay. Negative acceleration does not mean retardation. Does not mean retardation. That is, I'm making you write this because some books, some authors, some teachers say that negative acceleration means retardation. That's not true. Okay, even positive acceleration can be retardation, and it is also possible that even if the acceleration is negative, then also it is not retarded. Let's see very simple example. Suppose some object, this one, let's say, is moving towards the negative speed. Did you understand?
Yes.
And its velocity is -1, but acceleration is +5 into second. Is this retardation or not retardation? Is this retardation or not retardation? How do you decide? Is it retardation or not?
Yes.
Look at direction. What's the direction of velocity? Negative.
Negative.
What's the direction of acceleration?
Positive.
So are they opposite?
Yes.
So is this retarded motion?
Yes.
Okay. Fine. Now, how about this? Is this retardation or not retardation? No. Why not? Acceleration तो negative है. But velocity and acceleration both are in same direction, and that's not called retardation. Understood this warning? Negative acceleration does not mean retardation. There are cases possible where even if the acceleration is negative, still it is not retardation. Got it? Be careful with that. Right? Okay. I'm erasing the points. We are moving over to graphs. So earlier we have learned use of XT graph so far, right? Just making you recollect what we have learned. If there is an XT graph, then if you draw a chord and you find slope of chord, what do you get? Slope of chord will be equal to delta x by delta t. That is nothing but average velocity. Okay, right? Yes or no? Tan theta. But ultimately, this quantity is average. Similarly, if you draw a tangent and find out the slope of that tangent, okay, then that would be equal to dv vector by dx by dt, and that would be velocity. Clear or not?
Yes, sir.
Okay, everyone.
Yes.
So this is what we have learned about xt graph. Correct or not? We can find both of these. Right? Again, it's actually a chord, but if you shrink the time interval, it will become infinitesimal, and in that case, the chord will not touch at 2 points; it will touch at only
One
one
point.
point. So the chord will become
Tangent.
right? And that's why it's like that. Fine. I'm erasing this now. Just like xt graph, now we will talk about
VT
VT
graph.
graph. Okay, before what? Velocity. Okay, velocity time graph. To be very frank, I don't know whether you would have studied VT graphs in 9th standard. You have? Okay. So let's say that there is a VT graph. So we will learn how to find a few things from it. So first of all, suppose the VT graph is like this. Okay. So what we are going to learn is applicable for all shapes of graph. This is one type. And I want to find the average acceleration between T1 and T2. So this is an interval. Yes or no?
Yes.
This is delta T. Clear? Everyone recollects that?
Yes.
And suppose here at this T1 time the velocity is v1 because it's a VT graph, it's x1 and v1. Okay? And at T2
X.
the velocity is v2. Okay? Right? Fine. Then if we draw a chord from this point to that point, here's the chord. Do you see, just like we had it in the case of the XT graph, there was everything. Yes or no?
Yes.
So here, if I will say this is a chord AB, for example, of this graph, then I can say average acceleration, which is equal to delta v vector by delta t. Now this is delta t, of course, this side, and this side is delta v. Yes or no?
Yes.
Or not clear? No way to બોલી દો તમે તમને સવારે જ હતી. Clear? v2 minus v1 delta v. So from this triangle, delta v upon delta t should be equal to v2 minus v1 from this triangle using some trigonometry. What should this be equal to? Opposite upon adjacent. That is nothing but tan theta. Yes or no?
Yes.
Okay. And like I have said it earlier, that in language of mathematics, whenever you draw a line and it makes angle theta like this, then tan theta is called slope. So this is slope of what line? It's a chord. So slope of chord of which graph? VT graph. Very good. Confusion હવે ચાલુ. બેમાં slope of chord. Slope of chord of XT graph, average velocity. Slope of chord of VT graph, average acceleration. Yes or no?
Yes.
બરાબર ને? એટલે ધ્યાન રાખવાનું. Which graph is? અહીંયા જોઈ લેવાનું પહેલા. Okay, see the slope of chord, average velocity. You know યાદ રાખી દેતા. It might be wrong if the graph is VT. Okay. So this is what we get. Now, I'm sure you are half expecting, you have it in your intuition, what we should be writing for this. Can you tell me? What do you think? What should I write? First of all, I should write dv vector by dt. Yes or no?
Yes.
Acceleration. Then what do you think will happen here when we try to use this graph? It will be tan theta. But what will be there? Tan theta is barabar. It's the least important part in my view. It will be what? Slope of tangent. Yes or no? Again, same story. Think about XT graph and average velocity, instantaneous velocity. Yes or no?
Yes.
If you take this time interval and what to do, if you start shrinking it, if you start making the time interval smaller and smaller, then what will happen ultimately? You will get that delta t tends to 0. And when that happens, this thing dv vector by dt will come. Is that okay or not okay?
Yes.
Instead of delta v by delta t, you will get dv vector by dt. Understood?
Yes.
So this means for getting acceleration from a VT graph, what you should do is draw a tangent at whatever point you want to find acceleration. Suppose someone says find acceleration at 2 seconds. This is an example. Suppose someone says find acceleration at 2 seconds. Then you take this point and draw a tangent. આવડે કે નહીં tangent draw કરતા હવે? It should just touch it like this. Okay, if it's not exact, then also it's fine. Nobody is going to check your drawing that detail. Okay, this is a VT graph. So once you draw that tangent, whatever is the slope of that tangent, you can extend it all the way till here, the angle theta. Or you can also draw one dotted line here and say this angle is theta. The choice is yours. Whether you draw it here or here, theta is the main. Alright? Did you complete that? What should I write now? A vector equal to dv vector by dt equal to tan theta equal to slope of tangent. बराबर ने? Of which graph?
VT graph.
Okay. Completed. Slope of tangent of VT graph. तो याद रख दो પછી. Again, it's not compulsory to draw all the way till here. Even this would do. અહીંયા કરना તો કઈ ચાલે. The main thing is you should know which angle you're finding. Angle between line and on the positive side of the axis. Okay, done. Let's learn to use this concept. Once again, I am going to remind you the basics. Do you remember this?
Yes, sir.
Okay?
Yes.
Which line has zero slope?
1.
Which line has negative slope?
4.
Which line has maximum slope?
3.
Very good. So suppose this is a VT. And the velocity time graph of some object is like this. Right? Suppose the velocity time graph of some object is like this. Okay, how do I extend to like here? So here's the point A, here's the point B, and here is the point C, and here is D. Right, 4 points again. So what this graph is telling you is as follows: that here suppose velocity was, for example, 10 meters. Then first the velocity is rising, increasing. Yes or no?
Yes, sir.
समझ पड़े ना ग्राफ में? यहाँ 5 होएगा, 10 1 minute. Then what happened? Then it started decreasing.
Decreasing.
Yes or no?
Yes.
Okay. So first simple question: at which point is object at rest? What's meaning of rest? Can someone tell me? Raise your hand. What is meaning of rest? થાકી ગયો એવું નહીં. Resting, not like that. What is meaning of rest? Okay, very good. બધા try કરે છે, મને કઈ હો એ તો. Okay. Right. Clear. What's your answer? It does not move. એવો જ meaning હતો કઈ થોડું આમ exact નો. Stationary is a synonym. But when do you say some object is stationary? When it does not move. એવો answer નહીં આપ્યો. એક બીજો answer. When it is zero. Who is zero? હું ઘણી વાર બધાને કહું કે ફિઝિક્સમાં છે pronouns use નહીં કરવાના because it becomes very tough to understand what you are talking about. It, what is it? When what is zero? Yeah, there will be a Sorry? No motion occurs. But can you complete that? When something is zero. Generally we like to talk about quantities. We say object is at rest when something is zero. What's that something? Yes, he. Correct. When velocity is zero. याद है कि नहीं?
Yes.
કોને યાદ है? अच्छा, तो हमने કોને કીધું હતું? ઇમ્પોર્ટન્ટ પોઈન્ટ્સ માં આપણે લખ્યું
Yes.
એટલે જ હું તમને કહું છું કે ફોર્મ્યુલા તો ખાલી તમે ફોર્મ્યુલા વાંચી લેશો તો એમનાથી કંઈ બહુ થવાનું નથી. The sentences they are very 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 useful, right? આવી બધી સિચ્યુએશન માં તમને બાર કાઢ લેશે. Okay, we know that. Fine, sit down. Well tried both. All right, everyone. So where is the object at rest? We will do that. So that means where is the velocity zero? Follow.
D.
Okay. Everyone has seen the graph?
Yes.
Everyone has decided their answers?
Yes.
Sure?
Yes.
Anyone wants to see the graph more? You want to stare at it? Sure?
Yes.
Done?
Yes.
Decided your answer?
Yes.
Close your eyes. Okay, who says at A? At B? Close your eyes, everyone. C? D? Who says both B and D? Who says only D? Who says only B? Okay, open your eyes. The correct answer is only D, not B. Only D. अच्छा, मैंने कब एकदम से फिर? In the morning we learned something. ये वजह तो नहीं? ये वजह तो नहीं? Those who said B, yes or no? What was that? Here the slope is zero, so velocity will be zero. Yes or no? अच्छा, ये काटो तो सवाल है question. Take graph और नोटिस करते कि नहीं? यानी क्वेश्चन जब मैं ड्रॉ कर होते हैं, नहीं? I hope it is there. Okay. Okay, what graph was that? What graph was that? XT graph was that? Okay, in XT graph, the slope of tangent gives zero. In XT graph, slope of tangent is equal to slope of tangent in XT graph is equal to what? Tan theta તો એનું તો કઈ કામ નથી. tan theta તો આપણે tan theta કેવું હોય તો મેથ્સ ના ક્લાસમાં જતા બરોબર ને, કારણ કે એમને ઈ કામ છે આપણા માટે વેલોસિટી કામ. Yes or no? Sure? Everyone gets that?
Yes.
Okay, slope of XT graph gives you slope of tangent of XT graph gives you velocity. Sure? अच्छा, तो એટલે તમે અહીંયા કીધું કે અહીંયા tangent નો slope tangent horizontal એટલે slope 0. So velocity is also 0. Yes or no? That was your logic. Which graph is this? એનો તો કીધું confusion હવે ચાલુ છે. What you thought was for XT graph and which graph is this? Sure?
Yes.
Okay. So in VT graph what does slope give? Slope of tangent in VT graph. A VT graph છે કે નહીં first of all?
Yes.
Okay, in VT graph what does slope of tangent give?
Acceleration.
Not velocity.
Velocity.
So here is velocity 0. નથી ને, in fact 10 કરતા વધારે છે. You see here the velocity is more than 10. But where is the velocity 0?
D.
Clear or not clear?
Yes.
એટલે કહું છું ખાલી છે ને words યાદ નથી રાખવાના. You have to understand what it means. એવી રીતે કરો. What it? Okay. Of course, remembering it is the first thing to do. But then you should also understand it clearly what it is telling you. So at which point is the object at rest? Answer is only D. Not at B. Clear? Let's go to second. Okay. At which point is object speed increasing? At which point is object speed increasing? Hurry up. When does speed of an object increase? Pehla eno answer appo, basic. When does speed of an object increase? Mean. Sorry? In case of acceleration. Always if there is acceleration, speed will increase. Refer the point. Because yes, namaste.
When velocity and acceleration are in the same direction.
Correct. Very good. When velocity and acceleration are in same direction. Yes or no?
Yes.
Okay. Sit down, please. Clear? So we want to find a point where velocity and acceleration are in same direction. Okay. Right. So first of all, let's go to A. At A, acceleration positive or negative?
Positive.
One guess positive. One say. Please raise your hand clearly. Who is saying it's positive? Anjali, why is it positive? Yes, we will draw a tangent at A, right? Because if you, in a VT graph, if you draw tangent, what does tangent give you? Slope of tangent gives you acceleration. In which graph? VT graph. Here or not? So at A is the slope of this line positive or negative?
Positive.
That means acceleration is also positive. Got it? Sure? Sit down. Well done. So here acceleration is positive at A. Fine? Sure? Okay. What about velocity? Is velocity positive at A or negative at A?
Positive.
Positive.
Yes.
Sure?
Yes, sir.
How do you know? It's more than 10. Isn't it? More
Yes.
than 10 the positive or the negative?
Positive.
Clear?
Yes.
So at A, okay, let's make a kind of a table. This is A, this is B, this is C, and this is D. And here we will write down the signs of velocity and acceleration. Signs समझ पड़े थे? Plus, minus, or zero. So at A, what have we concluded? Velocity is positive. Yes or no?
Yes.
Sure.
Yes.
Acceleration
Positive.
positive because the slope of that tangent is positive.
Positive.
Okay. So here, will speed increase or decrease?
Decrease.
Increase. Got it? So A will definitely be the answer. Now let's go to B. At B, velocity positive, negative, or zero?
Positive.
Positive, negative, or zero?
Positive.
Zero नहीं?
No.
होना तो zero कहता था.
No. Extra.
It's not zero. It
Yes.
is positive because it's more than 10. You can see that. Okay, chalo. Now acceleration
Positive.
positive.
Yes.
How do you know? Here, to find acceleration from VT graph, what to do? Slope of tangent. So tangent draw carry.
Yes.
Look at the tangent. Does it have positive slope? Does it have zero slope? Or does it have negative slope?
Zero slope.
Zero
Zero
slope?
slope. Yes.
Yes or no?
Yes.
How do you know? It's horizontal. Correct? No slope.
Yes.
Clear or not clear?
Yes, sir.
Sure.
Yes.
So at A, acceleration is
Zero.
zero. Why zero? Because the slope of that tangent is
Horizontal.
yeah, the tangent is horizontal and the slope is zero. Fine.
Yes.
Let's go to C now. Velocity at C. Positive
Positive.
or negative?
Positive.
Sure.
Yes.
Okay. If you say so. Now acceleration.
Negative.
To what?
Yes.
Ten की વધુ નથી acceleration.
No, sir.
This is velocity. Draw the tangent. Tangent slope. Tangent slope. Negative, isn't it? Going down. Is that clear or not clear? So tangent slope is negative. That means acceleration is
Negative.
okay. Now your speed to that. Increase or decrease?
Decrease.
Decrease. Increase or decrease?
Decrease.
Decrease.
Yes.
Why? Is that okay?
Yes.
Do you see the answer? No. Question is about increase. Is that okay?
Yes.
Similarly, at D, velocity is zero.
Zero.
Acceleration?
Zero.
Same zero. Happens. આમ છે. અહીંયા graph પૂરો થઈ ગયો. Is that okay or not okay? At D, acceleration is negative. Clear or not clear? I am not saying graph is like that afterwards. It's just ending here. That's it. Fine. So at D, the acceleration is negative. So what will be the answer to this question? A. Fine. We will continue with more questions the next. Turn it off.